In this video, I want to talk about how to do regressions involving dummy variables. We've seen that sometimes these variables are coded as 0, 1. So those are fairly easy to interpret, and JMP picks them up cleanly. But we may have cases where our dummy variables may actually be text values. So in this data set, we have different engine displacements. We have cars of category compact, mid-size, and large. And then we have a quantitative variable engine displacement. We also have a dummy variable for fuel type, whether the fuel type is premium or regular. The question asks us to build a model in which we're going to explain the mileage of the car as a function of engine displacement as well as the class of the car. And what's also specific is that it is asking us to have a dummy variable for mid-size and a dummy variable for large. So compact car will be the omitted category. There are a couple of ways of doing this in JMP. Let's see one way which I think is more intuitive than others. So if you normally would do a regression like this, we have compact, mid-size, and large. So alphabetically, we first have compact, then we have large, and then we have mid-size. So if I go to Analyze, Fit Model, and move my highway miles per gallon as my dependent variable, and move my class and displacement as my independent variables, and click Run, what happens is that JMP defaults to removing the last category as the omitted category. Because we included all three, would have the dummy variable trap. So JMP removes the last category and then gives us results in terms of the other remaining categories. So if I click on the regression equation, so we see that our basic intercept, if we didn't have this variable, would have been 31.12. To see the impact of compact, we would subtract 2.09 from this intercept. To see large, we would subtract minus 0.028, and to see mid-size, we would add 2.377. However, it's not intuitive from here. So what we can do is we can actually recode the values so that compact now becomes the last category. And once we do that, then this will automatically be omitted from our regressions. To do that, we would go to the data table. I click on this column, right-click, click on column info, and then we look at column properties. And here we'll choose the option value order. So this is where we can reset the ordering. So the default again is alphabetical, where compact is the first one, large is the second, and mid-size is the third one. If I click on reverse, now mid-size becomes my first category and compact becomes my last category. So now we run this model, compact will be the omitted category. We could have also just moved compact down by clicking on compact and moving it up or down with this arrow. So we click apply and click OK. And now if I run this regression model, analyze, fit model, Y is my highway, and fuel and displacement. Sorry, class and displacement are my independent variables, and I click run. So here we obtain results with intercept being 31.12 and then class mid-size being 2.377. So, and large being minus 2.8986, which is not significant. So it seems that cars being large doesn't have any discernible impact on mileage compared to the compact car. But for mid-size cars, we see that miles per gallon is actually higher compared to the compact cars. If I obtain the prediction equation for this one, we will see the same results though, but in a different form. Here, we kind of see that the compact car comes up first because now it is giving us the ordering based on that, but the results are exactly the same. So results are identical, whether we have data organized as compact cars being the first category or them being the last category. In either case, our intercept is 31.127. And to find the highway miles per gallon for compact car, we would subtract minus 2.09 from our intercept, which is the same in both the cases. For large, we subtract only minus 0.286. And then for medium, we would add 2.377. So I think this is a cleaner way of seeing how each of these individual car sizes impact our highway miles per gallon. And in both these regressions, as we see, we had not done anything to displacement. The coefficient or the estimate on displacement is still minus 1.66.
There is one key difference, though, in interpreting the results of this model than the one that we would had we used a 0-1 binary variable for mid-size and large. JMP by default produces results at the mean level of all the values. And this is different than when we just indicate using indicator variables as 0-1. So to obtain the results that you would, were you having a separate column for mid-size as 1 and then large as 1 with compact being the omitted category, we have to make a little change. And that change is that we click on this red arrow, click on estimates, and click on indicator parameterization estimates. So once we click that, these values that we get displayed are the values that you would have gotten had you just had explicitly coded your displacement into class mid-size, 1, 0 for a mid-size car and 0 for a non-mid-size car, and large, class large equals 1 if the car belonged to the large class and 0 if it belonged to a different class. So in this case, we see results are slightly different. Here, compared to the compact car, a mid-size car adds mileage by 4.46 and a large car adds miles per gallon by 1.8, and both are statistically significant. The results for displacement, though, stay the same because we did not really do any tweaks to this. So again, the default of JMP is without the negative parameterization. It's at the mean levels. To get the results you would normally get if we had these explicit categories, we would go to estimates and then click on indicator parameterization estimates. We can also check that this is indeed what we will get if we were to have unique categories for mid-size and large. And we can do that by actually explicitly coding this. So I'm going to create a new column, go to formula, and here we can use a conditional function. Conditional functions are if-else, so I click here. If the expression, so we say that if my class double equals, now because this is a text, I'm going to do double equal and write mid-size. Then 1 and else 0. So if we say OK, we get this column which I can just call mid-size. So we get only mid-size cars. And if we scroll down, we see that this is 1 when the car is mid-size, and when the car is large or compact, it is 0. We can do the same for large. We will just do, we'll call it large, and let's create a formula. Again, we'll create a conditional formula, so I'm going to choose the if option here, and then if our class, again, equals large, then give us 1, if not 0. And we click OK. So now we have a column for large and a column for mid-size. So now if we run our regression model, we go to Analyze, Fit Model, and our highway miles per gallon stays as a dependent variable. For independent variables, we include now whether our car is midsize, large, and displacement. And we run this. So the results we get for this model are the same as we would have gotten with the indicator parameterization option chosen, and which is this. So this is the result that we get when we were to have explicit values for medium, mid-size, and large cars. In JMP, to get these, we can just go to indicator parameterization, and that option will give us the same results.